Welcome to homework.
Hi, here for the first question. In an absorption coefficient experiment, the absorption coefficient is a measure of how much material absorbs incident radiation at a specific wavelength. It is typically represented as a value between 0 and 1, where 0 means 0% absorption and 1 means 100% absorption. If you replace the glass with a material that has 100% transmission, it means that the material does not absorb any incident radiation. So, the correct answer is option C, absorption is equal to 0%. Replacing with the glass with the material that has 100% transmission results in no absorption of the incident radiation, and all of it is transmitted through the material. For the second question, in an absorption coefficient experiment where you replace the glass with water, the light intensity will typically decrease. Water, particularly in the visible and ultraviolet spectrum, can absorb and scatter light, which results in the reduction in the intensity of transmitted light. The absorption and the scattering of light in water are why, for example, underwater environments appear darker or less illuminated compared to the same environment in the air. So the answer is option B. For the third question, in the absorption coefficient experiment, when the thickness of the material through which the radiation passes decreases, the radiation intensity typically increases. This is because there is a less material for the radiation to interact with, resulting in reduced absorption or attenuation of the radiation. So the correct option is option B. Now, for the fourth question, in an absorption coefficient experiment, when the thickness of the material decreases, the absorption generally decreases. This is because there is a less material for the incident radiation to interact with, resulting in reduced absorption or attenuation of the radiation. That is option C. Moving to the fifth question, correct answer is option B, false. In the absorption coefficient experiment, the relationship between absorption and transmission is typically inverse. As transmission increases, more light passes through the material and absorption decreases. This is because absorption and transmission are complementary process. If more light is transmitted, it means that less is being absorbed by the material and vice versa. So, an increase in transmission corresponds to a decrease in absorption. Moving to the sixth question. In an absorption coefficient experiment, the transmission T is defined as the ratio of transmitted radiation to the intensity of incident radiation. If the intensity of incident radiation is equal to twice the transmitted radiation, that is I is equal to 2IT. That is T is equal to IT by 2IT, which is equal to 1 by 2 is equal to 0.5, which is option D. Moving to seventh question. The options provided, advantages, disadvantages, advantages and disadvantages, nothing mentioned, do not directly address the question about the total transmission of a laser beam in an optical fiber experiment. In an optical fiber experiment, the total transmission of a laser beam refers to the total amount of laser light that is transmitted through the optical fiber. It is a measure of how efficiently the optical fiber transmits the laser light from one end to the other. The options you have provided do not answer the question. The total transmission may vary depending on the factors like the quality of the optical fiber, the wavelength of the laser light, and the potential loss in the system. The answer to that question about the total transmission would depend on the scientific details and conditions of the optical fiber experiment, and it is not covered by the given options. Moving to the eighth one, answer is B, false. the output power of the laser irradiation is less than the input power of laser irradiation, it indicates that there are losses in the system. In the context of an optical fiber experiment or laser transmission, this means that not all of the input laser is being efficiently transmitted through the optical fiber. Efficiency is a measure of how well a system converts input energy into a useful output energy. In this case, the efficiency is not good because some of the input power is lost or absorbed by the system, resulting in a lower output power. Moving to option 9, question 9, the answer is option A, efficiency decreases. If optical fibers absorb laser irradiation, it means that some of the laser energy is being converted into heat within the fiber rather than being efficiently transmitted. This results in a decrease in efficiency because the laser energy is not fully and effectively transmitted throughout the fiber. Moving to the 10th question. Option correct answer is C. They have single wavelength light. In optical fiber experiment, lasers are often used because they produce highly coherent and monochromatic light. The single wavelength characteristic of laser is essential for various applications of optical fibers, including telecommunications, medical procedures, and data transmission, as it allows for efficient and high quality transmission of light through the optical fibers. I hope the solution is clear. Thank you.